Hi, I'm Justin Millard, Vice President of Exploration for Eminent Gold. Today we are going to chat a bit more about our Hot Springs Range project, as we refer to it HSRP. HSRP provides a unique opportunity to take a home run swing at discovering a world-class Carlin-type gold system, as has never before been explored or drilled, but has all the hallmark indicators of hosting a Carlin-type system. For more on the HSRP origin story, please watch our portfolio overview video. Nevada is world-renowned for being the type locality for Carlin-type gold deposits. They make Nevada one of the most well-endowed gold jurisdictions in the world, with over 200 million ounces of gold endowment attributed to this deposit type alone. As we zoom into northeastern Nevada, we are looking northwest along the axis of one of the most richly endowed pieces of real estate on the planet. On the left is the Battle Mountain-Eureka Trend, with over 15 million ounce gold endowment and growing. In the center is the Northern Nevada Rift, with numerous greater than 1 million ounce low sulfidation epithermal deposits. And on your right is the Carlin Trend, with over 115 million ounces of gold and growing. In the distance, spanning left to right, is the Getchell Trend, with over 42 million ounce gold endowment and growing. And you'll see, sitting immediately adjacent to the intersection of the Battle Mountain-Eureka Trend, the Getchell Trend, and on the western flank of the Northern Nevada Rift is the Hot Springs Range project. HSRP has components of both Carlin-type mineralization in the older rocks and components of low sulfidation epithermal in the youngest rocks, suggesting both generations of hydrothermal activity were active at this location. As we fly northwest, we will review what is going on in the immediate neighborhood of HSRP. HSRP is directly analogous to the Turquoise Ridge District of Nevada gold mines. The two systems share nearly identical geologic framework, and for the layman, this means that the faults or breakages in the rocks that form the plumbing for the gold-bearing fluids are analogous. Some geologists may even argue that they're part of the same system. And we'll take a quick look at the framework of Turquoise Ridge before venturing on to HSRP to see these striking similarities. We are looking at a geologic model at the Turquoise Ridge District, with notable intercepts in drilling shown as red disk. The main geologic framework feature to point out at this scale is the three primary deposits: Turquoise Ridge, Twin Creeks, and Vista. These deposits are largely controlled by where the feeder faults and cross faults intersect. The most important feeder fault in the district being the Getchell Fault. It continues southward and controls I-80 Gold's Granite Creek deposit, and also extends northwards where it becomes obscured by valley fill on the southeast side of Eden Valley. We believe the Getchell Fault resurfaces in the bedrock in the Hot Springs Range on the northwest side of Eden Valley, where it obliquely offsets basement rocks right laterally down to the east, and our technical team has found it to be mineralized. As we rotate into a cross-section viewing perspective, we will also see that trapping the gold-bearing fluids at depth are thrust faults in the coincident ideal host rocks of carbonates, that is limestones, and iron-bearing volcanics, that is mafic volcanics or sills. The carbonate rocks cause the acidic gold-bearing fluids to neutralize, and this is no different than taking a Tums on an upset stomach. The iron-bearing volcanics form sites for gold to attach onto, and this is no different than eating that greasy pizza or burrito after a binger at the local pub. It settles things down, and iron forms a site for gold to attach to. In these sections, we see both HSRP and TR. They effectively are the same geometry, and if we look closer, they have the same ideal host rocks of carbonates and volcanics that are thrust atop deeper basement rocks and then are cut by feeder faults. Returning to map view, we see these ideal host rocks extend northeastward, effectively making a gold deposition site that we now know as the Getchell Trend. The only component you also need is a spatially coincident plumbing system for gold-bearing fluids, and that is the feeder faults and cross faults. So now that we got TR understood, let's fly north to see the geologic framework of Hot Springs Range. HSRP has analogous structural framework as Turquoise Ridge, albeit at HSRP there's a thicker package of younger unmineralized cover rocks that obscure the majority of the system. At HSRP we have northwest-southeast oriented feeder faults, northeast southwest-oriented cross fault, and a sub-horizontal thrust fault that places a plate of carbonate and volcanic rocks atop phyllites and shales. From where the ideal host rocks are exposed at Otis, they extend northeastward to Eden. As we zoom into Otis, we see the primary northwest-southeast feeder faults down-drop the ideal host rocks to the east. When our mineralized were exposed on the footwall side of the Getchell fault equivalent.
The Hot Springs Range project has two target areas. The western one we're on right now is the Otis. Our technical team identified exposure of the mineralizing system through a soil anomaly with gold up to 465 parts per billion. Also through mapping, identified the exposure of a large thrust fault and feeder faults for the system. The thrust fault has gold values up to 0.7 grams per ton from rock chips. The feeder faults have values up to 2.8 grams per ton. Geophysics done last season has identified where those structures intersect at depth behind me in this hill. The hill is covered by post-mineral sediments and volcanics. We're going to drill test at depth those structures intersect, and we're currently constructing roads for the drill pads in the coming season.
We are now viewing a simplified 3D geologic model of the Otis target in the Phase 1 drill plans to test the northern structural block. Color balls are the surface rock samples. The warmer the color, the higher the gold concentration. White lines are planned diamond core holes. Our initial holes will test mineralization along the diorite sill on the shoulder of the system and test the intersection where the primary feeder faults, cross faults, and thrust faults and host rocks coincide with the strongest conductivity anomaly. The Otis target cross-section reveals how the conceptual target of steeply dipping feeder faults are linked to map structures on the surface that host gold. Additionally, the conceptual target coincides with a robust conductivity anomaly we interpret as the result of argillic alteration of the carbonate and andesite host rocks. All of these components of the blind target are exposed to the west and display diagnostic characteristics of a Carlin-type gold system. As we fly eastward, we will pass from the edge of the exposed system where the thrust fault daylights and the first mineralized sample was taken during the 2019 staking campaign. As we summit the ridgeline, the Otis target will come into view. The ridgeline is held up by the well-mineralized diorite sill, a feature previously unrecognized in USGS mapping. The presence of the sill suggests that the HSRP fault system is regionally plumbed into the diorite Osgood stock immediately adjacent to the Turquoise Ridge deposit. Consequently, this suggests that both HSRP and Turquoise Ridge are part of the same crustoscale hydrothermal system. The Otis target is defined by the intersection of multiple feeder faults, cross faults, and where geometry indicate these faults had the greatest degree of permeability to allow gold-bearing fluids to migrate and pond in our host rocks and thrust fault at depth. As we crest the backbone of the Hot Springs Range, we can see eastward greater than 10 kilometers, where our primary cross faults extend to the second target at HSRP, Eden. Mapping and geophysics indicates that Eden possesses the same geology as Otis, but it is obscured by a thicker package of post-mineral cover. Eden lies roughly 10 kilometers to the east, where mapping indicates the same host rocks of limestones and andesites are thrust atop phyllites at depth, beneath roughly 300 meters of post-mineral cover. This target is analogous to the Twin Creeks deposit in the TER district, albeit at Eden there are no bedrock exposures of mineralization. Instead, recently active normal faults with scarps on the surface are geochemically anomalous with gold, arsenic, antimony, mercury, selenium, and rhenium, with selenium being a proxy indicator of the presence of hydrothermal sulfides at depth. These elements are being scavenged and remobilized to the surface during recent fault ruptures. Further, geophysics identifies a large conductivity anomaly above the inferred thrust at depth, a signal of potential argillic alteration similar to that observed at Otis. We are now viewing a simplified 3D geologic model of the Eden target in the Phase 1 drill plans to test the intersection of the feeder faults, cross faults, thrust fault, and inferred ideal host rocks at depth.
For more project details, please visit our webpage. Thank you for your time.